I'm going to start this problem with just about where we left off today in class. Take a look at this question, number 61. Classify each of the following reactions as one of the four possible types from table 19.4. That's the one that we had on the board as we were leaving class today. So in this one, delta H is negative, delta S is also negative. Will it be spontaneous, or under what conditions will it be spontaneous? So I'm going to work one with you just to see how this works. So delta G equals delta H minus T delta S. Delta H is negative 249 kilojoules. Negative T times negative 278, or 0.278, becomes positive 0.278. Again, I converted to kilojoules by dividing this by 1,000. Okay? So let's take this 249 to the other side. Let's letting this be 0, because that's our equilibrium point. That's our point at which the Gibbs energy will be neither spontaneous in neither direction. So let's just work this out. So this goes over to the other side. It becomes 249 kilojoules equals T times 0.278 kilojoules. So T turns out to be 249 divided by 0.278. So that number turns out to be 896 degrees, 896 Kelvin. You could argue that that's a fairly high temperature. So look at this for just a second. Here's the question we're asked to solve. Which kind of reaction will this be? So delta G equals delta H minus T delta S. When T is greater than 896, when T is very, very warm, this term becomes a large negative number that's more negative than this term. And so, even though entropy is negative, as long as the temperature stays below 896, as long as it's below 896, this term will be smaller than the delta H term. So 896 is the threshold. As long as it's lower than 896, it's going to be spontaneous. So I would argue that this one is spontaneous under low temperatures. Let's look at the next one, part B. Part B, we have delta H as positive. That's an endothermic reaction. We have S as becoming more ordered. That's kind of weird, isn't it? So it's an endothermic and becoming more ordered. So that's negative. Looking at the formula here, you can see that if this is positive and this is negative, there's no temperature that you can work into this problem that becomes negative times a negative is always going to be positive. Delta H is positive. This one is never spontaneous. Under no conditions is it spontaneous. Now let's do the last one, part C. Delta H is positive. That's an endothermic reaction. Delta S, though, is becoming more ordered, so delta S is positive. Okay? Well, this one, if the T delta S term, delta S being positive, as long as the T stays big, then delta H is going to not be overwhelmed by the large T. So in this one, it is spontaneous at high temperatures. So it's spontaneous at high temperatures. Any questions?